All right, guys, so I'm not here today, and what I've decided to do is because the test scores were a little lacking, I've decided that everyone should retake the Unit 1 test. And I really want to show you guys in this video how to study for a math test, because I'm not sure a whole lot of studying happened, and if it did happen, I'm not sure how effective it was. So no judgment on my end, but I think this is a learning opportunity to go through and talk about what was on the test and how you can study for it. So the best way of thinking about a math test is kind of like a performance, like a musical performance. So if you're a musician, imagine you're a rock star and you get up on stage to play the guitar. You have played that song probably thousands of times before, and each time you play it a little bit better, and you work through mistakes. And that's the same thing with a math problem. And for a test, what you do is you encounter a question and you say, can I do this? And if you can't do it, then you do questions like it over and over and over again until finally it becomes easy for you. The idea here, guys, is for difficult things to become easy for you through practice. And that's a life skill that'll extend beyond math into other areas of your life. So enough of my monologue. You all have this handout. It's either green or yellow. Green and yellow are the same. And it's a review for the end of unit test. Now, what I want you to do right now is open up your Chromebooks and get Canvas. Open up my Canvas page and we'll go from there. So if the sub can pause the video now, that would be great. Okay, so you've opened up your computers and you should be going into Canvas. And in Canvas, go here to Modules. And at the bottom, near the bottom, there's something here called Review for the End of Unit Test. Now, this is something you should have done on Thursday night before the test, but let's do it now for those of you who haven't. And if you have done it, still open this up, Review for End of Unit Test. Now, I'll pause here for the substitute to go around and make sure everyone is at this page where it says Review for the End of Unit Test. Okay, so you'll notice here the first three questions all have to do with finding the slope between 2 points. Now I want you to look at your handout, and your handout looks really similar because the first three questions on the handout are the same type of question. How do you find the slope between 2 points? Now I've given a formula here, and let's talk about where that formula comes from, how to use it with the first example, and then I want you to use the same template to do the first three questions on your review on Canvas. Okay, so let's talk about this formula here. Let's see if I can get this to mark up. So let me zoom in. And yeah, we've got this formula right here. And I just want to talk about where the formula comes from, because knowing where a formula comes from is really helpful in using it. So let's say I have this point right here called x1 comma y1. And I have this point over here called x2 comma y2. And I want to find the slope of the line between those 2 points. Now, these letters are a little confusing, so let's call these guys, let's just say we have the point 3 comma 7 and 2 comma 4. So with the slope, we're trying to find the rise divided by the run. So how much something goes up divided by how much it goes forward. So if you were looking at this point and you wanted to find the rise, you would say this point right here, this is at 4, and way up here, this is at 7. How much did I rise? And you would do 7 minus 4. Now let's do that same thing though, just with the letters. With the letters, we're doing y2 minus y1. The difference between the y values tells you how much you rise up. Now let's look at the x values. Let's imagine this x value, or this x value is 2, this one's 3. And to find the run, 3 minus 2, it's the difference in the x values, and 3 minus 2 is going to be 1. So here, same idea, it's the difference in the x values. That is how much you run. So the rise divided by the run is the slope. Okay, that's where the formula comes from. Now let's go ahead and use it. So here is this example. I've got these points. Now see where it says y2? In the formula where it says y2, I'm going to replace that with -1. And instead of y1 here in the formula, I'm going to replace that with that 2. Now on the bottom, x2 is 5 minus, and then this right here is negative 3. Now remember that it's minus whatever the x1 value is. It happens to be here that the x1 value is negative, so I keep that double negative. And all right, so I got negative 1 minus 2. How am I going to deal with the double negative? The negative negative is going to be a positive 5 plus 3, so I end up getting negative 3 over 8. So my slope is negative 3 over 8. Now what I want you to do now is go to this, your reviewed thing, and see this question. My question here is 3, 4, and negative 5, negative 4. So if you're doing this, what I would do is head over here, and for this question, you're going to mark this guy up here, and my point was 3, 4, and negative 5, negative 4. And I want you to solve this out and doing exactly what we did just now. Get your answer, and then once you get your answer, you're going to plug that answer in to Canvas. So I got negative 8 over negative 8, which I think is going to turn into 1. Let's just see if that's right. And you're going to plug this in here, and the answer is 1. And so whatever it is, you'll enter that in, and let's just say we try this. And if you get it wrong, then hit get a similar question and enter something in. Keep on doing it until you start to get these right. So I'll go ahead and pause the video here, or the sub will kindly pause the video here, and I want you to spend a few minutes doing questions 1 through 3 until you start to get these right consistently. Okay, welcome back. I'm glad that something clicked, for some of you at least. Let's move down here and talk about questions 4 through 6. So I'm going to do an example, and then I'll let you loose to do this on Canvas. So let me mark this up. Let's talk about how to do this.
Gray Honda Accord, white Honda HR-V, and a black Chevy.
All right, so this is what I call the box method. So here I've got 3x minus 1. We're going to put 3x here, going to put minus 1 here. Here I have 2x, and I have 4. Now, we're going to multiply these things together. Let me just take a step back, just so you guys know what we're doing. Otherwise, it might seem completely pointless to you. Let's say we wanted to do something like 12 times 14. Well, I certainly can't do that in my head, but I can think of 12 as 10 plus 2, and I can think of 14 as 10 plus 4. Now, instead of doing a box that's just 12 by, let me erase that. Instead of looking at this and just going 12 times 14, I can actually look at this and say, what if I had a box that's like that? Now I can do 10 times 10 is 100. 10 times 2 is 20. 10 times 4 is 40. 4 times 2 is 8. And so I have 100 plus 40 plus 20 plus 8. Adding those up together, I have 168. And I've just multiplied 12 by 14. We're going to do the same thing here, except with letters. So we're going to do 3x times 2x. First you do the numbers. 3 times 2 is 6. X times x is xx, which we write as x squared. Now we're going to do 2x and negative 1, negative 2x. Now we're going to do 3x and 4, that's going to be 12x. And finally we're going to do 4 times negative 1, negative 4. So we're going to write this out now as 6x squared minus 2x plus 12x minus 4. Now are we done? We're not done. We've got to combine some like terms. These guys are both x's, so we can combine those together. We've got 6x squared. This is negative 2x plus 12x. It's the same thing as 12x minus 2x. That's going to give us 10x and then minus 4. And so that's going to be the answer. Now, same thing as before. I want you to go here to your question. We're at question 4. And question 4 here for me, I got x plus 4, 3x minus 4. You're going to come back over here, and you're going to type those guys in. So we've got x plus 4, 3x minus 4. Yours is going to be different from mine. And you just start multiplying across, and you know how to do it. And so I'll go ahead and have the substitute pause the video right now, and you can work through questions 4, 5, 6. Okay, welcome back. So now that we've done questions 4, 5, 6, hopefully something clicked and you're getting these. You can add some notes here and these bullet points if you want. Let's talk about questions 7 and 8. So for these guys, let me mark this up. So this right here is just the distributive property. So we're just gonna have this guy hit this guy. And now 2 times 4 is 8, and I've got a couple of x's, which are as x squared. The 2x is gonna hit the negative 1, so minus 2x. The negative 3 is gonna hit the 4, minus 12x. Remember, it's the negative 3 that's hitting the 4. That gives me the negative 12x. And it's the negative 3 that's hitting the negative 1, which gives me a positive 3. Now, just like before, we're going to combine some like terms. That's going to be 8x squared minus 14x plus 3. So let's go ahead and pause the video here, and I want you to do questions 7 and 8 and enter those into Canvas. Okay, great. Hopefully that clicked for you. Let's go on down here to question 9. Now, question 9 is one of these questions that I want every single person to get right on the test, because once you see the trick, it's actually not that hard. So let's go ahead and think about 4x to the 5th and just kind of break this apart. That's just 4 times 1, 2, 3, 4, 5 of those. Now, what about the 20x to the 4th? Well, 20 is 4 times 5, 1, 2, 3, 4. And finally, we've got 12x to the 3rd. That's 4 times 3 times x times x times x. Now, what's something that all of these have in common? Well, they all have a 4 in common. That's a common factor. But we're not done yet. They also have some letters in common. They have an x in common. They have another x in common. In fact, they have 3 x's in common. So their greatest common factor is 4x to the 3rd. Now, let me tell you just kind of a shortcut way of doing this question. What you're going to do is you're going to look at these numbers, 4, 20, and 12. And you're going to say, what number goes into 4, 20, and 12? And a 4 goes into all of those. Now you write the letter x, and you write the smallest exponent here. The smallest exponent is 3. And that's it. That's all you have to do. Just to show you how easy it is, let's pick another question here from the review and do this. Let's skip down here and do question 9. So question 9, I have 2x to the 4th, 14x cubed, and 10x squared. So what's a number that goes into 2, 14, and 10? That's right, 2 goes into all of those. So if I was entering my answer, I would write 2x, and the smallest exponent is the 2. So the answer here is 2x squared. Looking at 10, something that goes into 15, 6, and 3 is 3. So here I'd write 3m squared. Looking at 11, 21, 6, and 15, 3 goes into those. I'd write 3x cubed. So just now, guys, I did 9, 10, 11. They're really easy once you see the trick. I want to do these until they really click. Don't stop, guys, until all of these click and you're getting these right 100% of the time. So I'll pause the video now. Work on 9, 10, 11. Okay, let's go ahead now, guys, and talk about questions 12, 13, 12, 13, and 24. So linear function. How do you tell if something's a linear function? Okay, you guys know this. If it's a linear function, then you go up or down by the same amount each time. So let's draw this pattern here in this table. So let's say, let's pick a number 7, and let's go up by 4 each time. 7 plus 4 is 11, plus 4 is 15, plus 4 is 19, plus 4 is 23. This is an example of a linear pattern. Let me just make this really clear here. We're going up by 4 each time. So if you can add the same thing and get to the next number in the series, then you're good to go. You're linear. Okay, exponential. Exponential is where you multiply by the same amount each time. Okay, so let's fill in this table here. Let's start with a 5, and we'll just times it by 3. 5 times 3 is 15, times 3 is 45, times 3 is 135, times 3 again is, what, 405 maybe? So here we are multiplying by 3. That's our common ratio. All right, now quadratic. These guys are a little bit trickier. Quadratic is where you have a common second difference. So let's scoot over here and talk about this. Let's do this pattern. 1. First of all, is it linear? Can I add plus 1, plus 3, plus, no, not going to be linear. Is it exponential? Can I times it by something? Times by 4, times by, no, it's not linear, it's not exponential. We can actually use process of elimination and say it's quadratic. But we can also do one step further and talk about that second difference. Gap between 0 and 1 is 1, between 1 and 4 is 3, between 4 and 9 is 5, this is 7. So the pattern here is 1, 3, 5, 7, and if we do the difference of these guys, we get 2, 2, 2. And so the second difference is the same. All right, what I want you to do now, guys, is do questions 12, 13, 24. So the substitute can kindly pause right now and you guys work on 12, 13, 24. Okay, welcome back, guys. Question 14 is one that was really tricky for a lot of you guys. So let's go through this one really carefully. For this one, let's plug in -1. It says evaluate f of -1. So here the 3 is the same as before, but instead of writing x, I'm writing -1. The negative comes down, the 2 comes down. Instead of x, I'm writing -1. Everything else is the same. All right, now the first thing to do, I want you guys to make a note right here and say exponents first. So the first thing we're going to deal with is that -1 squared. And let's talk about what -1 squared looks like. -1 squared is -1 times -1, and negative makes a positive 1. So this whole chunk right here, that just turns into a 1. Let's rewrite this now. 3, 1, -2. Okay, so if we did exponents first, then we do multiplication second. And we're going to multiply these out. So 3 times 1, well, that's easy. That's just 3. Here, we've got to do that -2 times -1. And -2 times -1 is a +2 plus 2. 3 plus 2 plus 2 is 7. That's your answer. What I want you to do now is to pause the video and evaluate f of -2 right now. Okay. Let's do this guy. So f of -2, we're going to do exponents first. So -2 squared is going to be +4. So 3, 4, negative 2, positive 4 plus 2, 12 plus 4 plus 2, 16 plus 2, 18 is our final answer there. Okay, so what I want you to do right now is on your paper, do question 14. Make sure you show your work here and take your time. So do question 14, enter it in, make sure you get it right. Let's pause the video. Okay, welcome back. Question 15. This is something that I want every single person to get right. This is not a hard thing once you know the trick. And the trick here is to read the notation. Now, the notation here is this. What does it mean when we say f of 3? It means what's the y value when x equals 3. So here, what's f of 3? It's 82. Okay, I want you guys to all think of the answer to this one. What's f of 5? 27. When x is 5, y is 27. What is f of 9? If you thought in your heart of hearts that the answer is 29, then you thought correctly. That's all there is to it. Easy, easy, easy on that one. Okay, let's scroll down to, let's see. Let's scroll down to this next one right here. We're gonna find f of 1. So this is the same thing that we talked about before, where we're just trying to find the y value when x is 1 or whatever. Let's try to mark this up. So f of 1, this is the y value when x equals 1. So I circle 1, I go down, 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 down to there, then I'm gonna go over, 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 and I get negative 3. When x is 1, y is negative 3. Okay, this next one I want you to think about, what is f of 3? So think about this. And if you said 1, then that is absolutely correct. You start here at 3, you go up to there, and you go over here to 1, so f of 3 is 1. Okay, I want you guys to do these questions right now on Canvas. Do questions 15 and 16. You should be getting these right. If you're not, keep on hitting refresh question until you get these right, until it clicks for you. Okay, welcome back. For questions 17, 18, 20, 21, and 22, there is one idea that's going to help you get these right every single time. Well, two ideas. How do you tell if something is not a function? So two different ways here. Number one is the vertical line test. So let's draw a graph like this. And if I can make a vertical line that cuts through it in more than one spot, then this has failed the vertical line test and it's not a function. Okay, so let's do another one here with some points. Let's say I have this point here and this point here. It's still a function, right? Because a vertical line isn't going to slice through more than one. But if I put another point here, all of a sudden that is no good, because this violates the vertical line test. One vertical line cuts through 2 points. So check if the vertical line cuts through 2 points, not a function. Second way to tell if it's a function is if the x values repeat, then that means no function. So let me show you what that looks like in a table. Let's just scroll down here. And let's say I have x and y. And I've got 0, 7, 2, 8, 5, 11, 2, 24. Well, here, let's just graph this to connect it to the vertical line test. So 0 goes to 7, 2 goes up to 8, 5 goes to 11, and then all of a sudden 2 goes way the heck up here at 24. So the number 2 gives me a 24, the number 2 gives me an 8. So this is an example where the same input gives me two different outputs, and it's a little confusing, it's a little crazy, and it's not a function. So here, if you're looking at a table, you're seeing, do any of my x values repeat? So you can kind of think of this with 2 is with 8, so 2 is in a relationship with 8, but now 2 is double dealing, and 2 is also dating 24. 2 is being unfaithful, 2 is not a function, it's not being consistent. So look for those repeated values to see if that something's not a function. So right now, guys, go ahead and do questions 17 and 18. We'll get to the other ones later. Okay, question 19, domain and range. So for this one, let's refresh what domain is. Domain has to do with the x values. So you're going to say how far to the left, comma, how far to the right. Only looking at the x values. So let's just trace this graph. Right here, I'm at 0. I'm at -1, I'm at -2, I'm at -3. That's the furthest to the left I can go. So for the domain, I'm going to write -3. Now let's follow this to the right. I'm at -1, or I'm at -2, I'm at -1, I'm at 0, I'm at 1. My x value is at 1, I can't go any further than 1. Now, you've got to make a decision whether to do rounded brackets or these square brackets or rounded brackets. If you see a filled-in circle, you use the square ones. If you see an open circle, you use the rounded ones. So here at -3, that's a filled-in one, so we're going to do that. Over at 1, that's an open one, so we're going to go, we're going to do the rounded brackets. Okay, so that's the domain. Now for the range. The range is all of the y values. So let's scroll on down here. So the range is y values. So let me write that in. And you write the number furthest down first, comma, the number furthest up. And the only thing I look at the y values. So if I'm tracing this right here, I'm at 0, -1, -2, -3, -4, -5. That's the lowest I get. So first I write -5, comma, and I'm tracing this up. I'm at 1, I'm at 2, I'm at 3, I'm at 4, I'm back down to 3. Now, it's not about where you arrive, it's how high you got eventually. And the highest we got here was up to 4. So we're going to look at -5, that's a filled in one, that's a square bracket. What about 4? There's no dot up here at 4. So for here, we use a square bracket. If I'm a little bug going on a little roller coaster up here, I will get up to 4 before I go down again. So we include that 4 in our range there. Okay, I want you guys right now to do this question, question 19, and I want you to redo it a few times until you're getting it right. So I'll pause now. All right, question 20. Let's do this one fast. So question 20, we need to talk about the domain. Domain is x values, so we just list the x values. We list 8, we list 6, we list -5, 3, -10. Now this is important. I want you to write a note here. Remove any repeats. So looking at my numbers, anything repeat? Nope, so we can leave it as it is. Let's say I had a point that was like 8, 11, then I wouldn't write another 8 here because 8's already there. So don't include repeated values, just one of them will do. All right, then the y values are just going to be -10, -7, 17, -1, -2. And again, you always check for repeats in the range too. If there's some number repeats itself, erase it. It only has to appear there once. Okay, and here, because the x values don't repeat, it's going to be a function. All right, so do question 20. Let's pause the video. And now let's go and do question, this guy. Okay, so for this one, let's just do this guy fast. So if you see something like this, where the graph kind of goes all the way to the edge of the paper, you can assume that it's going on forever. So domain is how far to the left we can go. Well, here there's really no limits to how far to the left we can go. We can go all the way to negative infinity to the left and all the way to positive infinity to the right. Because we never actually arrive at infinity, we're going to use the rounded brackets, saying that it doesn't include it. Now for the range, we first talk about the lowest value. So if I'm on this thing, riding this roller coaster down, 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 the lowest my roller coaster gets here is -2. The highest it gets, well, there's no limit to how high it gets, so we're going to do -2, infinity. Now it includes the -2, square bracket doesn't include infinity, rounded. Is it a function? Yes, it is, because the vertical line test, the vertical line will only cut through at one point. All right, now, the last page, go ahead and turn to the last page. This is important, and this is something we've done a lot, but it's something that's still kind of weak. The idea here is that we've got to come up with an equation based on a table. So the equation, we're going to write this out. This letter M is your slope, and it's also going to be the common difference. And B is going to be the y-intercept. Now here my common difference is going to be 19. We're minusing 19 at each step. So I can write this out. F of n is equal to -19n plus the y-intercept. Now the y-intercept is when x equals 0. On a graph, let me just graph this right here. If I have a graph right here and I have some kind of line, where the line crosses the point is going to be 0, something. So the y-intercept is when the x value is 0. Now if I'm looking at my table, the problem is that my x values are only 3, 2, 1. I want to go all the way to 0. So I've actually got to work backwards here and find out what number goes there. So the number that's going to go here is something, and that something is going to go and finish off the equation. I guess I shouldn't be lazy. Let's figure out what that something is. If we're going backwards, we're subtracting 19, so 33 minus 19, that's going to be what, 17? So this number is 17, -17. So here in my equation, it's going to be 19n minus 17, and that is my equation. Now for the recursive equation, it's going to look like this. F of n is equal to f of n minus 1, and then we're going to do minus 19. And what this is saying is that to get the next x value, I subtract 19 from the previous y value. Let's go now. We don't have time in class because I think we're running out of class time. Let's go ahead and just skip down to this exponential one, and I want you to read this last page really carefully and study it and do the examples, because this is a really critical problem on the test that a lot of people missed. So right here, let's mark this up. Here we've got an exponential model. And exponential models, this k is the y-intercept, and this a is our common ratio. And we can tell this is exponential because we're timesing by 3, timesing by 3. So we got f of n equals the y-intercept, same deal. We've got to work backwards on our table. When n is 0, let's work backwards 4. And just see if that works. 4 times 3 is 12, times 3 times 3, cool. So now we're going to write this 4 times, instead of the letter a, we're going to write our common ratio, which is 3 to the n. We're using the letter n on this guy. Okay, for the recursive, to find the next y value, we're going to look at the previous y value, and what are we going to do to it? We're going to times it by 3. And that's it. So to find the next n value, you look at the previous one and you times it by 3. For the test, you don't have to include the initial condition, which we normally would. The test, you can just write that guy in there. Okay, guys, I know this is a lot, but I think if you study really hard this guide, that you will understand it really well. and you'll do super well on the test. So spend a good chunk of time tonight studying. Wish you the best of luck, and I'll see you all when I get back.